Hi, I'm Willow Chandarina, Product Manager with the Amazon Elastic File System team. In today's session, we're going to be talking about how to modernize applications using Amazon EFS and container and serverless. We're going to start by talking about why you might want to use containers and serverless to modernize your applications and how Amazon EFS fits into that. Then we're going to get started on the practical bits of how to actually set it up and what best practices you should keep in mind to make sure your applications are running how you want them to. So let's start out by why you might want to modernize your application in the first place. Customers that use containers and serverless technology to modernize their applications do so because they get three main benefits. First is agility. When you have compute infrastructure that can scale up and down with your application, it's really easy to handle the peaks and valleys of load that come during the course of the day or with any one-off events that might make your application busier than normal. Next, most customers that adopt containers and serverless also modernize their development practices with continuous integration, continuous delivery, and are able to get new features to market faster and be more competitive. Last, customers that hand over the management and operations of their applications to AWS ultimately do more operational work, they achieve higher reliability, and ultimately achieve lower cost as a result. Now, there's no shortage of options with how you deploy your application on AWS, on the compute side. There's a whole spectrum of choices that go everywhere from AWS Lambda, which abstracts away the majority of how your application actually runs on the infrastructure and lets you focus entirely on the code. And as you go down all the way to Amazon EC2, at each layer, you take on more control over how your application works, how it integrates with data sources, how it runs, how it scales. So you can, for each of your applications, pick which abstraction works best for you. With Amazon EFS, you don't have to pick one size or one approach for all of your applications. Instead, you can pick what's best for each application and use Amazon EFS to share data in between those applications. So let's talk about what Amazon EFS actually is. Amazon EFS is simple, serverless, shared file storage for your applications. It's simple and serverless because it's completely elastic with nothing for you to manage. So there's no servers for you to manage. You leave all that up to us. You don't pay for anything until you actually add data to your file system. So your file system scales with the data that you put in, and you only pay for what you use. Amazon EFS is a regional service, which means when you write data to EFS, we write it to at least 3 availability zones, and it's available from all availability zones in the region, which make it really convenient for modern applications, which we'll talk more about later. It's a shared file system, which means you can share data with between 2 instances of an application or even 2,000 or 20,000 instances of your application. So this can particularly come in handy if you have a Lambda function that needs to scale out to tens of thousands of parallel invocations. You can use a shared file system between all of those. You can achieve high performance with Amazon EFS, tens of gigabytes per second, hundreds of thousands of IOPS. And we have 4 different storage classes that allow you to right-size the performance, cost, and durability properties of EFS. We're going to talk through a few of those options later in the presentation. Now, when you take the key attributes of Amazon EFS and the key attributes of Amazon ECS, Amazon EKS, or AWS Lambda, the benefits of each of these services and the attributes compound on each other. For instance, when you use these services together, it is super simple. It's simple because you can configure EFS from the application definition, whether it's a task definition, a pod spec, or your Lambda function definition. EFS goes inside that piece so that you don't have to worry about how to manage the infrastructure. As an application developer, you use EFS just like you would local files. You open a file, you write to a file, you close the file. So it's really easy to use with your applications, especially if those applications already understand how to work with files. The availability and durability benefits stack as well, because all of these are regional services. So it means that you can use them to create a regional version of an application, which can be agnostic of which availability zone it's in and fail over from one to the other as needed. All of these services are elastic, so you don't have to worry about scaling any piece of your infrastructure. And we've integrated them in such a way that you can secure access from your data to your applications. We'll talk more about how to do that later. Now, when it comes to modernizing applications, there are two key approaches that customers go with. One is application migration, which means you take an application that's already running, let's say, on a physical server, an EC2 instance, and you move it into a modern compute framework, such as a container or serverless function. There's also application augmentation, which means you take the existing application you have and add some new capability to it by writing that new capability in something like AWS Lambda. And we're going to talk through some examples of each of those. Starting with modernizing using containers. So let's say you have this application running on a physical hardware instance or a EC2 instance today, and you want to modernize it. Chances are that application has some persistent storage need today where it's using block storage or file storage. So to modernize that application, first you take the application itself and you containerize it, and then you can launch it using Amazon ECS or EKS onto either EC2 instances or AWS Fargate if you want it to run completely serverlessly. And then you can use Amazon EFS as the persistent layer to replace whatever block or file storage that you had on the original application. Now, the reasons why you might want to do that, or the reasons why you might want EFS to go with your container, typically fall into one of two categories. Either you have a long-running application that needs to be stateful or recover from any sort of failures that might happen, or you have data that needs to be shared between instances of an application or between applications. Let's walk through some specific examples of applications that customers are containerizing today. So one category is developer tools. Tools like Jenkins, Jira, Git all benefit from having a persistence layer because you don't want to lose source code or bug reports or anything if there's any sort of failure either at the application or the infrastructure layer. Next, web and content management systems are commonly modernized. So WordPress and Drupal instances can be easily containerized and run in serverless environments so that you lower the operations burden. Next, machine learning and associated tooling. So you can train machine learning models using MXNet TensorFlow, and you can run a lot of the common tooling that customers run in these environments, like notebooks or ETL tools like Airflow. I want to share a couple of case studies of customers that have taken existing applications that were running outside of containers and serverless and migrated them in. So one is a company called Acquia. Acquia is a hosting provider for content management systems. So they use open source Drupal and have their own layer of orchestration around it to make it easy for customers to launch websites and other content management systems. They recently migrated from using EC2 instances to using Amazon EKS to simplify the running of each of their container environments, each of their customer container environments. And they use Amazon Elastic File System as a way to make it easy to manage storage in each of those customer environments. And by doing this, they were able to get two main benefits. First, they simplified the operations of their environment, making it easier for them to onboard new customers and manage customer operations. And two is they made it easier to scale up and down an individual customer environment as the load on that customer site changed. Another customer example is Federated Wireless. Federated Wireless is a wireless provider that uses consumer broadband spectrum in order to provide new services to their customers. And with this, it's important for them to run analysis to make sure that they're using that spectrum in a fair and safe way. Previously, they were running their analysis outside of containers, outside of EFS. And by migrating into EFS, they were able to simplify their overall operations and actually speed up these analyses. And as a result, they're able to scale out to run more jobs and ultimately understand how they're doing in more areas and onboard new devices. Next, let's talk a little bit about Lambda, which is commonly used for augmentation or creating new pieces of an application to augment your functionality. So with this, the way to take existing pieces of functionality is you've got some code running on, again, a server, an EC2 instance, and you're going to deploy that code to Lambda, and Lambda is going to be responsible for launching instances that code runs on and interfacing with Amazon Elastic File System in order to save state or share session data between different instances of the same function. So one example of a use case for EFS and Lambda is machine learning. Now, with machine learning, there's of course two parts of it. There's training machine learning models, and then there's running inference or serving predictions using that ML model based on new API calls coming in. It's common to use Lambda for the inference component because it can scale up and down according to load. And a challenge that customers have had in using Lambda for inference is in cases where the model file is larger than 512 megabytes, or library files are larger than 512 megabytes, or the data that you need to do the inference based on is large. There wasn't enough space in the Lambda functions already. Now with Amazon EFS, basically what you can do is attach unlimited storage to your Lambda functions and be able to run any sort of inference application with Lambda. An example of a customer that's doing this is Asurion. Asurion's a company that sells extended support contracts on customer electronics. And they are, for their call centers, using ML inference in order to evaluate customer experience on audio files from customer care calls. And in doing so, they can better understand their customer experience. Another use case is data pipelines. So this is the act of taking some piece of data in and either chopping it up or doing interim processing before you put it in some final location. This is common to do with Lambda because you can divide up the work that needs to be done into discrete functions and pass data between them. But if that data that you need to pass is large, it may not fit in the Lambda temp space. And that's where Amazon EFS can help. So an example of a customer that's doing this is called Skywatch. As the name suggests, they process satellite imagery. And that satellite imagery, those files can be quite large. So they were able to move their data pipeline functions into Lambda by using EFS to store those large files as they move through. So now that we've talked about why you might want to do this, let's talk about how to actually get started. Now, before we get started with actually how to configure it, it's helpful to talk about how to make sure that you can do this in a secure way, because getting this right up front will set you up for success later. Now, your goals for security typically come down to two things. One, you want to make sure that if you have a file system, it can only be mounted by the applications that are allowed to mount it, the applications that need to mount it. Next, once those applications mount the file system, you want to make sure that they only have access to the data that they need. And we're going to talk about how to do that. First, to make sure that applications can only mount the file systems that they should have access to, we've implemented Identity Access Management, IAM, policies to make sure that you can configure which applications, or using the IAM role of that application, can mount which file system. And you can do this using either identity policies or resource policies, using actions of client mount, client write, or client root access. So you can control which granularity each application has when mounting the file system. Next, in figuring out how to give an application access to specific data in the file system, it's important to understand how identity works in these modern application environments. So let's say that you have a container running, and that container was built to run the application inside as root, which is a common practice. When you mount a file system from that container, and that container does a file system operation, it's going to tell the file system that it wants to do operations as root, because that's what the application is running as, whether or not that's what you actually want it to be running as. It could be dangerous to let an application run like that because it means it has read and write access to all files in your file system. So the important thing to keep in mind here is the identity of the application comes from how it was built, not how it was run, which may or may not be how you want it to run. Now with functions, it's a similar story, except there's no real identity built into the Lambda function. It can be anything. So it's a non-deterministic identity. It's difficult to think about how to offer permissions against something that you don't know what it's going to be coming in. Now it's because of this that we introduced a feature called EFS access points. To understand what they do, let's just look through the definition of one. So we see here in the access point definition, there's two key pieces. One is called POSIX user. So in this case, we have a user ID 123, group ID 123, and a list of secondary groups. What this says is any application that connects through this access point will be rewritten to this user and group, which means you don't have to worry about what identity the application has on the compute side. You only have to worry about which identity you give to the access point. So now you have control over which user an application operates as, which is important for access management. The other thing that you see in this definition is the root directory. So here, it's a common case where each application that comes into a file system should have its own private space, maybe its own private directory. Using this root directory, you can say what the home directory for an application should be. And in the case that that directory doesn't already exist, you can say how you want it to be created, what permissions it should have. So again, there's two key benefits of using this. One is to enforce file system identities, so you don't have to trust the identity of whatever was built into a container. And two is to create application-specific directories so that you can effectively share file systems between applications. Now we can see this in action. So that same application that was built to run as root is now doing file system operations. But since it connected through an access point, those operations are actually being done as user ID 123. So it has a predictable experience. Now, the last thing you may be wondering is how to make sure that a particular application can only use a particular access point. And for that, you can use IAM policies in order to map a specific IAM role to an access point using a condition key. So now that we've talked about how to set up the identity piece of it, let's actually attach file systems to your applications. So starting with Amazon ECS. For this, I'll just simply show the UI version of it, because basically what you want to do is configure a volume within your ECS task definition to refer to the EFS file system. So if you're in the console, you can click Add Volume, which brings up this modal, and you simply say that you want the volume type to be EFS, and then you specify what file system ID you want to attach, which access point ID you want to attach, and a couple of other options. You would later configure where you would want this file system to be mounted into your container using the container side of the task definition, and then you're done. So you would do it this way, whether you do it from the console, the CLI, or the API. It's just creating a volume. Next, let's talk about Elastic Kubernetes Service, or any Kubernetes containers. With Kubernetes, we've integrated EFS with the CSI framework, the Container Storage Interface. And in doing so, we support all of the standard interfaces that administrators and developers expect when using a Kubernetes storage environment. I won't get into all the various details here, but one thing that I do want to call out is recently we're excited that we now support a new mode of creating persistent volumes called dynamic provisioning. So what I want to do right now is talk a little bit about how that works and how it's different than what we did before. So with dynamic provisioning, instead of creating file system resources up front, creating persistent volumes up front, and then later mapping them to developer requests coming in, everything can now happen automatically. So the way it works is a user comes in because they want to launch a new application, a new Kubernetes pod, and they create what's called a persistent volume claim. That persistent volume claim goes to the EFS CSI driver, and then the CSI driver on the user's behalf will go to EFS and create an access point. That access point will have a unique identity and it'll have a unique directory. So it'll create a private space within a file system and map that to a persistent volume that is then handed back to that user. So now administrators don't need to be in the path of new applications getting deployed on Kubernetes. Now last, how to get connected to a Lambda function. Here, again, I'll show an example using the console. Here, you simply create your Lambda function. You click on the button to add file system, specify which file system you want to add, which access points you want to connect using, and that's it. Of course, you want to make sure that your function is running in the same VPC as your file system and that security groups allow communication between your function network interface and EFS. So now that you know how to connect, let's just make sure we go through some best practices so that your application runs as best it can. So with security, we talked through a lot of this already. So I'll just summarize the major things to make sure you do. So enable encryption at rest. A lot of times it's on by default, but just make sure there's no penalty for turning it on. Same thing for encryption in transit. Use EFS access points. They're easy to get started with, and they, even if you don't need them right away, they can future-proof your application for later needs. Make sure when you configure them that you don't leave user ID and group ID blank. Things aren't going to work if you do that. And then enable IAM authorization. It's a lot easier to manage access from applications to EFS using IAM than it is to manage network policies and security groups and things like that. So when you create a file system, you have a choice between two performance modes. There's general purpose and there's max IO. The key thing to keep in mind is for most applications, general purpose is the right choice. And the reason for that is because general purpose mode file systems are optimized for latency. So anytime you're doing any operations that are latency sensitive, such as many small file operations, so unzipping a file or doing anything with Git or anything like that, you'll benefit from the lower latency of a general purpose file system. The cases where you might want a max IO file system is if you are parallelizing your application among hundreds or thousands of parallel instances, and the latency of operations doesn't matter as much as how many parallel IOPS that you're doing. So this might be what you want to do for a scale-out analytics job or machine learning. But I'd advise you always to start with general purpose, using max IO only in the specific circumstances where you benefit from the IOPS. Now, we've made several performance enhancements recently that I want to call your attention to. Last year, we had a 5x increase in the number of IOPS that we support on a general purpose mode file system. We increased the amount of throughput you can drive for each client by 100% from 250 megabytes per second to 500 megabytes per second. And we tripled the amount of read throughput that you can drive on a file system in all cases. On the latency side, we've been doing a lot of work on this as well. We haven't had any announcements, but we've been chipping away at the latency. So over the course of last year, we lowered the latency of EFS by 3x. So here you can see a benchmark, which is doing git clone, which is a latency sensitive operation, and how we have improved our performance 3x already to the baseline. So if you haven't tried EFS for latency-sensitive workloads recently, I'd advise you to try again. So best practices for performance, again, start with general purpose file systems. Configure provision throughput to make sure that you have the throughput that you need for your application, especially if you don't have a whole lot of data stored yet. And use Amazon CloudWatch to monitor everything about it and make sure that you have enough throughput and IOPS for your application. Now, cost management is always important. You want to make sure that you're getting the best use of your Amazon EFS resources. So another thing I'd recommend using is lifecycle management on EFS and EFS infrequent access. So when you turn on lifecycle management on your file system, we will automatically move files to lower cost storage after it reaches some threshold. And you can set that threshold from 7 days to 90 days, where if you haven't read or written a file in that amount of time, we will move the bits to lower cost storage. Customers that turn this on save up to 92% on their total storage bill, so it's definitely worth doing. Next, we recently launched one-zone storage classes for Amazon EFS. So with one-zone storage classes, you can lower your cost by up to another 47%, so as low as 4.3 cents per gigabyte a month. So this is great for applications that can run in a single availability zone. So this could be used in dev and test environments or in any applications that don't need regional durability. Last, always turn on backup for your file system. You never want to be in a case where your application comes up and accidentally changes a file or deletes a file. So when you turn on AWS Backup, it can keep backups of all of your data. It'll keep them in low-cost storage and always give you the option to pull files back as needed. And last, make sure that you check out all of the resources that we have for training and certification. Thanks for watching my session today. It's been a pleasure talking with you. Happy containerizing on your applications.